Good evening, Professor. My name is Thilagan, working in PPG coating, currently pursuing Masters in Analytical Chemistry in UPM. So today I'll be presenting a video about a research proposal and experimental design as a part of the Master Program course. The outline, this is the outline of my presentation. I will begin the presentation with the introduction, where I will talk about the edible oil and the misuse and the types of misuse using edible oils, as well as the available analytical method to distinguish good and bad edible oil. The second is the problem statement. I'll explain the issues related to the misuse of edible oil and the challenges encountered during the analysis process. The third is literature review, where I selected three published journals related to this topic. And the fourth is objective, where I'll show my objective based on this research. And the following one is the experimental design. I'll briefly explain about the process flow of the experiment and the setup, as well as the methodology behind the analytical method. And last is the expectation. The outcome of the experimental result should be in the expected range, and the question raised during the earlier stage of the experiment should be answered at the end of the experiment. Edible oil is an essential food consumption for human beings due to the presence of unsaturated fatty acid, which is very beneficial to human beings. And the types of edible oil available is soybean oil, olive oil, sunflower oil, but I'll keep my interest with palm oil as it is the one widely used in Malaysia. And there are various ways of incorporating edible oil into the foods, but the most common way is used to deep fry food. Deep fried food can enhance the flavor, the color, the texture of the foods. Yes. Next is the oil adulteration. This term defines mixing used oil with the fresh oil. As the demand for the deep fried food is very high, chances of counterfeit of edible oil is also very high. The reason behind this is simply because of cost. Fresh oil produces more cost in preparing food. Thus, people tend to mix used oil with fresh oil to reduce the cost of production. From economic point of view, replacing high-priced oil with cheaper oil is profitable for producers and encourage them to do so. The analytical method available for analyzing the edible oils can be broken into two. One is conventional method, the other one is modern method. Conventional ways of analyzing edible oils usually is titration and also calculating the iodine and peroxide value. Besides identifying the specific gravity, refractive index, and saponification value, modern ways of analyzing edible oils is performed based on the qualitative analysis. Available methods are chromatography, spectroscopy, and electrochemical sensor, but I'll be focusing more on the spectroscopy type of techniques. And challenges encountered in the analysis usually is time constraint, sample preparation, data analysis. Challenges encountered in the analysis method where the conventional way is very long process, require more time, and the sample preparation is very tedious process. The same condition can be applied to chromatography technique. However, for spectroscopy, these challenges can be tackled, but require very competent person to decode spectra reflected from the sample. This table shows the past research paper done on the edible oil characterization using spectroscopy analysis, accompanied with chemometric studies such as principal component analysis and partial least squares analysis. So from here we can see the research is done based on the adulteration concept, where the oil sample is the actual oil and the adulterated using the other different kind of oil, and the analysis done based on the spectroscopy method, uh, also accompanied with the analytical tools such as principal component analysis. This table shows the specification of the edible oil that can be considered safe to be consumed based on the Malaysian standard. Our focus will be on the RBD palm oil. RBD means refined, bleached, and deodorized palm oil. Simply means it's a recycled palm oil. So problem statement. So health effects due to oil adulteration. Prolonged consumption of adulterated oil can cause cancer and metabolic syndrome. Edible oil often becomes impure and unfit for human consumption as a result of adulteration. It has been reported that adulteration of edible oil resulted in severe health issues in some cases. For example, I have chosen this Spanish toxic oil occurred in 1981. 20,000 person affected, approximately 300 died shortly after the onset of the disease, and a larger number developed chronic disease. The cause of this phenomena is because of ingestion of rapeseed cooking oil that has been denatured with 2% aniline and illicitly sold as olive oil. Obscurity in identifying fine edible oil. For food producers to have the knowledge of chemical compound present in the edible oil is very less. Hence, they usually only consider the color of the edible oil. As the color gets darker, then only they replace or replenish the oil with fresh oil. This activity thermally can degrade the quality of the oil by producing more chemical compound that could bring negative effects to human health. Analyzing method is a tedious process. Sample preparation for certain analyzing method is very complex as few separation steps is required to remove impurities from bulk matrix. This step is performed to reduce the error that can occur during the spectroscopy analysis and also to concentrate the target analyte. Literature review, as I mentioned, I have chosen 3 types of literature about a published journal related to this research topic. The first is detection of fresh palm oil adulteration with recycled cooking oil using fatty acid composition and FTIR spectral analysis. For this, the adulterated oil is homemade, where they bought locally sold fresh oil and use that oil to deep fry banana fritters and chicken nuggets for a certain period of time till the total polar content reached 24%. Then this oil further processed to become recycled oil, where deodorization and degumming, bleaching is performed. Then this recycled oil is mixed with fresh oil in ascending order, different amount of concentration, and perform the FTIR analysis. The outcome of this experiment is significant occurrence of all chain fatty acids, monounsaturated fatty acids peaks, also the diminish of polyunsaturated acid peaks. The second journal is a qualitative analysis of Suran 4 in edible palm oil. Suran 4 is a type of dye used to enhance the color of palm oil. The palm oil sample is locally collected, also prepared in-house, and the sample analyzed using surface enhanced Raman spectroscopy. And the significant peaks is observed in the adulterated oil due to the presence of dye. The third one is application of Raman spectroscopy in the rapid detection of waste cooking oil. Waste oil used to adulterate fresh oil and overheated oil prepared a sample for Raman analysis. And another hypothesis developed in this journal is overheated oil also can reflect the same character as the adulterated oil. Performing the Raman spectroscopy shows this occurrence. of unknown peaks in adulterated oil and overheated oils. The further studies conducted using HNMR technology technique shows oxidation degree for corresponding peaks from Raman spectroscopy. Then proceed with PCA analysis, shows these clusters clearly for adulterated oil, overheated oil, as well as the fresh oil. The common factor for these three journal is application of spectroscopy and observance of unknown peaks, observance of unknown peaks due to the adulteration. But for Raman spectroscopy, the resolution is much more higher. That's because the wave number range is from 800 to 1008. And for FTRI analysis is from 1000 to 4000 wave numbers, which shows the resolution for Raman spectroscopy is much more higher. The objective of my research title is to collect used oil sample from restaurant and street food vendors, compare with fresh oil. Fresh oil will be adulterated with used oil using different concentration in ascending manner. And the second is to analyze sample collected using Raman spectroscopy for adulterated oil, fresh oil, and used oil. And the third is to analyze the result plot using PCA to identify the clusters occurring. Experimental design. So experimental design I plan for this research is as shown. So sample collection where I picked two location only, restaurant and street market. For restaurant, I chose a grade A type of restaurant only because mostly grade A types of restaurant reflects the same identity. Also, the restaurant should be provide a similar kind of food to assume that the oil used for meal preparation will be the same for all the 5 restaurants. So sample oil will be collected from the grade A restaurants and mixed together to become homogenized and stored at room temperature to stimulate the external storage of a food producer. The next is the sample oil collection from street vendors. So for this, I give myself to be able to collect oil from limited specific food producers only, where only starchy food producers is selected for this case. The reason behind this is because deep frying meat products releases protein juice from the meat to the oil, which will give rise to the unwanted peaks from the analysis. This explanation was given in the research journal I mentioned before using the FCRI analysis, where they assume that deep frying chicken nuggets can release protein juices that shows unknown peaks in the FTRI spectra. Next is the sample preparation. A simple filtration will do due to the presence of the residual flours and chicken bones. So we need to remove that. Then sample preparation, fresh oil. We prepare few set of fresh oil sample. Then adulterated oil, where we mix the sample oil from restaurant and the street market with the fresh oil in a ascending concentration order, 0%, 10%, 20%, 30%, 40%, and 50%. Two set of sample is prepared. One is from restaurant and the other one is from street market with the same condition. Then these two set of samples analyzed using Raman's spectroscopy wave number from 800 to 1008, and the significant peak is identified. And these results are plotted using principal component analysis (PCA) to visualize the distribution of the clusters and to identify the clusters occurred. So the expected outcome from this experiment is existence of unknown peaks in adulterated oil and diminishes of peaks in the spectra. And also the PCA plot should be showing the clusters occurrence for adulterated oil and fresh oil. And another important element is the analysis should be done swiftly in a very quick time, as that is one of the concern of this objective, as that is one of the objectives concerns. Yes, that's all. Thank you.